Hey guys, it's Code Zealot, and today we're going to learn all about raycasting in Minecraft Java Edition. Now, what I have set up here before us are a couple of test entities, a carrot on a stick, and also a scoreboard objective that detects whenever I use a right click with this item in my hand. So if you guys don't know how to set that up, you can go ahead and check out the other videos on my channel, but you will need to have that scoreboard objective in order to use the carrot on a stick in this way. Now, what we'll be doing here is showing an example of a raycast. And so if I go ahead and right click now with this carrot on a stick, we can see that a ray is sent out from the player and in a specific direction, which is basically the direction we are facing. And it is executing from the position of my head, which gives it, the location that we want. Now we can shift this. We can make this, shoot out from our feet or, shoot out from, 3 blocks to our right, whatever you want to do. But most of the time when people are raycasting, they want to shoot from the player's eyes because that is how we play Minecraft. You can see the crosshair on my screen is basically where our eyes go. And so whenever we want to do a raycast, typically we're trying to raycast to a specific entity or a specific block. And what we want to do really is just detect that block which is in line with the player's eyesight. So that's what we're going to be doing in this video, but we're also going to talk about how we can adjust that position as well. Now let's jump right into the code files here and see what we are doing to make this all work. So if we go over here to Sublime Text, we can go ahead and take a look at this MC function file. What's happening inside of this MC function file is really simple actually. These commands right here, this first one and also this bottom one which goes along with it, are completely optional and are just a safeguard that you can put into your data packs whenever you're using raycasting if you want to make things a little bit easier to detect when the player is actually using a raycast, but this is completely optional. So what we're doing right here is simply just looking to see if the player has used our right click detection and then giving them a tag which we can use to make the raycast not detect them inside of the ray. Now let's take a look at this command right here, which is the most important, which is the execute command responsible for calling our raycast. Now, what we're doing here is we're executing as all players who have used the carrot on a stick with our right click detection objective, and we're going to be executing this command at their position. Now, once we have that position, we're going to go ahead and shift it slightly. So what we're doing here is using positioned to raise it up 1.5 blocks up. And what that's doing is it's taking the position of the player who is executing this command, which is the player who has just used our right click detection. And then it is raising it up 1.5 blocks, which is typically the Minecraft player's eyesight level. Next, what we're doing is we are going to use another positioned here to position that command forward 2.2 blocks. And the reason for this is because we don't want the player to be detected inside of the raycast. They're the person using the raycast, and we don't want them to be picked up. And so we push it out a couple of blocks. You can mess with these values right here because if you've seen in my other tutorial videos, these notation marks right here called the carrots are able to position things from the player's facing value. So right now we're facing this 2.2 blocks away forward from the player. So you can make this farther out or closer to the player, and you can play around with using this tag if you want to get closer to the player for some reason. But like I said, the tag is completely optional, so you could do this all with just this command right here. Now, what we're doing once we have that position set is then we are testing if the block at that position is air. So remember, we're starting at the player's position, we're moving it up 1.5 blocks, and then we're moving it forward 2.2 blocks. And if that block is air, then we are going to go ahead and run our raycast function, which in this case is listed right here as CZ raycast example. So let's go ahead now and jump into our raycast example and see what is over there. Inside of our raycast example, we have 3 parts basically. The first is optional, which is displaying a particle as we saw in the beginning of this video that lets us see the ray that is being cast. And this can also be used to, have a particle effect in your raycast. So for example, in my spells, I use this all the time to make things like a fireball, display flames and all kinds of other things you can do just like that. So if you want to have a particle in your ray, or in other words, if you want your ray to be displayed as a ray of particles, this is where you would do that. Now we're just going to leave the barrier on there for now for debug purposes as we're going through this tutorial. But in the future, you could just comment this out if you wanted to, or you could switch it out as I said previously. Next, what we're doing is we're actually saying what we want to do with our raycast. Now, What we're going to be doing in this example is essentially just making the entity that we hit with our ray have the effect of glowing. And so if we go ahead and take a closer look at this command, what we're doing is we're executing as all entities who do not have that CZ Raycasting tag. Remember, this is optional. And then we are making sure that they are of the type not equal to our Raycast band list. Now, if you don't know what this is right here, basically what this is a custom tag for entity types. And I have that set up over here. So let's go ahead and just glance at it really quick and see that it's really just a JSON file. And inside of this JSON file, we have our values listed for all of the entities that we do not want to detect in our Raycast. And as you can see, they're all things like items, item frames, or armor stands, area effect clouds, things that we are not really looking for in our Raycast. And so we can go ahead and just list them all out like this. And then inside of our command, keep everything nice and clean with this simple list for the type. So what we're saying here, just as a reminder, is that we are looking for something that is not in this list. And then we are going to see if they are in a distance of 0.7 blocks away from the position of the Raycast, and we're going to limit it to just one entity. Now, once we have found that entity, once we have found an entity who is not inside of our band list, who does not have our optional Raycasting tag, and is now inside of that distance that we've specified, we are going to give them the effect of glowing with an amplifier of 1 for 1 second, and we're going to hide the particles, which is our true tag right here. The last thing we need to do is basically set up the looping functionality of this Raycast. So what we're going to be doing is using what's called a recursive function, and how this is going to work is basically the function that we are running right now, Raycast example, is going to call itself right here. And it's going to call itself only if it needs to. And so how do we know if we need to call the Raycast a second time, or a third time, or a fourth time, or an infinite amount of times? Well, the answer is quite simple. We need to know whether or not we found what we are looking for in the first place. And so if we haven't found what we're looking for, then we need to continuously search for it in a straight line. And so that's what we're doing right here. So what we're saying here is execute if the block at this position is air. And then we're going to reposition our command if it is an air block. And what we're going to do is we're going to lower our command by 1.35. And the reason for that is because entity hitboxes are usually at the feet of the entity. And so if we're going to detect the entity, we need to get their hitbox. And so what we're doing is we are seeing if the block is air, and then we are repositioning down to the feet of where the entity would be. And then what we're saying is if we don't find an entity right here, just like before, then we need to go ahead and continue by repositioning and also calling our function. And so we're going to reposition forward 1 block, and then we are going to reposition back up where we were previously, because we no longer need to detect the feet of the entity, because remember, if we haven't found an entity, then this part is going to run. So if we haven't hit the feet of an entity already, then we're going to go ahead and move forward 1 block, and then we're going to move back up to eyesight level of the player, and then we're going to run this function all over. And so what this is going to do is it's going to start back up here at the top. It's going to display another particle in our new position, and then it's going to do the test all over again for the effect that we want to give, and then it's going to run this all over. And so let's jump into game so we don't get too confused and see all of that in action. So when we right click, you can see that our function has run 1, 2, 3, 4, 5, a bunch of times because we haven't found what we're looking for. However, if we run it over here, you can see that it only runs a couple of times. In this case, it ran 3 times, and that's because it only had to move forward 3 times before it actually found the entity we were looking for, which was this handsome devil right here. Look at him. He's gorgeous. Anyways, now let's go ahead and see this one more time in another type of example, which may be easier for you guys to visualize. Let's say that this tree is the player who is going to do the Raycast. When they use the right-click detection, what happens is we are calling our function that is responsible for the actual ray. So when we call that function, something happens. The first thing that happens is a particle is displayed, right? So here is our particle. Next, what happens is we need to detect whether or not an entity is in this location. Now, remember what we were saying. The hitbox of the entity is usually at its feet, somewhere around here, and not, on a villager somewhere up here. So if you actually want to hit a villager, if you shoot like this, you can see I'm not hitting the villager because I'm not hitting the hitbox of the villager. However, if I shoot down by his feet, you can see he gets the glowing effect because we're actually detecting that entity. So what happens is after we display our particle right here, what we do next is we move our command down 1.35 blocks, which is right here. If there is an entity here, our loop ends and then we run whatever we were going to do, which in this case was give that entity the effect of glowing. Now, if there is no entity, then we need to continue our recursive function loop, which basically looks like this. We move back up to this position and we also move forward 1 block and then we run the function all over. So now that we're right here, we display our particle, we move down, we test for an entity's feet. If we don't find one, we move back up, we move forward, and then as you can tell, it keeps doing this over and over until eventually we do find the entity we're looking for, and then our loop stops. And since we found the entity, that command that we set up with the execute that looks for the entity there to give them glowing actually runs, and then our loop ends and our raycasting is over. So just to see it one more time, if I shoot this out here, you can see it runs over and over and over because it has not found what it's looking for. However, if I shoot it right here, it only runs a limited number of times because it's easily finding what it's looking for. And as I move farther and farther back, you can see that it's running more and more because the position we're starting at is farther and farther away from what we are looking for. So guys, if you enjoyed this video, go ahead and hit the like button. And if you haven't yet seen my latest video at the time of this video, which is all about my raycasting spells in Minecraft and the Datapack release download link for that as well, go ahead and check that out now. The video is now displayed on the screen for you guys to check out. So guys, I'm CodeZealot, and I'll see you all in the next video.